Good morning, everyone. Thanks for coming. It's a great pleasure, this opportunity of being here to talk a little bit about most of my PhD thesis results, where we developed this molecular phylogeny for Prosthechea. This project was carried out at the State University of Feira de Santana in Bahia, Brazil, under the supervision of Dr. Cássio Vandenberg, and also in collaboration with Gerardo Salazar from the National Autonomous University of Mexico. And yeah, so let's talk a little bit about this such a nice group, ORCID group, and the lumper splitter debate concerning it. So first of all, I would like to outline what will be this presentation. So in a first moment, I will be introducing you, like providing some context to you guys about the genus Prosthechea, talking about its diversity, distribution, and some of morphology. Then we're going to get into really briefly on the taxonomic history of the group and how we went to this lumper splitter debate concerning the group. To then get into the molecular phylogenetics of the group, uh, and presenting our results. Then the implication on systematics about our results, so to split or not to split Prosthechea after all. And then finally presents just some biogeographic considerations. So Prosthechea is a neotropical orchid genus comprising around 120 species. The plants can occur in a wide variety of types of habitats, since from lowland areas to high elevation mountains. But I would say that most of the diversity of the genus is concentrated in mountain forest habitats. So we have three main centers of diversity for Prosthechea. Oh, sorry. Mesoamerica, the tropical Andes, and the Atlantic forest in Brazil. So some pics here highlighting the diversity of the group. About the vegetative morphology of Prosthechea, the plants are sympodial, they can be cespitous or rhizomatous. The pseudobulbs can vary from ovoid to long, cylindrical, and slender. But a remarkable trait in the vegetative morphology of Prosthechea is that usually the pseudobulbs, they present at least some degree of lateral compression. So even without flowers, sometimes you can easily recognize some Prosthecheas. The inflorescence can be like simple racemes. Actually, most of the species present simple racemes, but some of the species also present panicles, like compound racemes. When you get to the floral morphology, that we have like most of the variation, as you can see here. So we have non-resupinated flowers, which means like flowers where the labellum has like an upside position. You can also have some species with resupinate flowers where the labellum at the display are in the lower position. And some variation also regarding the labellum morphology in terms of number of lobules. So sometimes entire, sometimes trilobed. But when we get to more detailed morphology in terms of the column of the group, we can find some common traits among all the species, basically. So usually not. Actually, the clinandrio is like always three-toothed. So as you can see here highlighted, we have this structure kind of holding the anther, and between the tooths we have like these deep sinuses that you can notice here, and also the mid tooth is usually modified in an appendage, so it's like a swollen projection. So actually the etymology of the genus come after that. So from the Greek, prostech means appendage. So for that, the etymology of the group. There's some variation also in the callus morphology. Usually most of the species present like simple elevated callus, which you call like a pad-like callus. But some others, as highlighted here in Prosthechea livida, sorry. The callus can present some varicose projections. There's some variation also in terms of indument. And here in Karvinsky, you can see like a more kind of lamellate sort of callus. The fruits usually are three-winged or at least strongly triangulate, as you can see here in the pics, which is kind of remarkable about the group also. And now getting really briefly into the taxonomic history of the genus, we must have in mind that actually most of the species currently circumscribed in Prosthechea, they were originally described as epidendrum during the 19th century. Later on, Dresler segregated Encyclia from epidendrum, and he subdivided the genus into two subgenera, the subgenus Encyclia and subgenus Osmophytum, based pretty much on those traits that I just highlighted before to you. And what Higgins did, he pretty much elevated this Encyclia subgenus Osmophytum to the generic level, and he could figure out that the oldest generic name associated to that set of species is actually Prosthechea. And for that reason, this recent reconsideration is on circumscription at the generic level. Then at the turn of the 2000s, with all this boost in terms of molecular phylogenies for the orchid family, mostly also at the subtribe level, Prosthechea started to be sampled in these works, but just including up to 18 species. So let's say 15% of the known diversity, and usually not covering out that morphology variation. In the more recent of those phylogenies focused at the subtribe level, it was recovered in a clade that was called as Encyclia alliance, together with other groups related as Encyclia, Arturima, and Alemannia as monophyletic. But after that, some alternative classifications were proposed, splitting Prosthechea into narrower genera. So first, Quirón and Castroneto proposed the subdivision of Prosthechea in a narrow sense of Prosthechea, sensu strictus, and pseudoencyclia based on traits of resupination and lip morphology and cosmorphology. So kind of this idea. And the 1 year after, Wisner and Harding proposed an even broader splitting of the group. So they subdivided Prosthechea sensu Higgins into 6 narrow genera, making use of some old names proposed previously, like Anacheilium, like Hormidium, Euchile not so old, but also already proposed, and proposed some new names such as Panarica, Pollardia, and the narrow sense of Prosthechea, using like a variety of morphological traits. Some of these groups are kind of better circumscribed in terms of morphology, usually like the smaller ones, but others kind of present like a bunch of overlap in terms of morphological traits. And now these works, these 2 alternative classifications were like essentially based on morphology. So at that point, we still have some very kind of basic questions, right? Like, is Prosthechea monophyletic after all? What about all these other alternative generic circumscriptions? Are those groups monophyletic? And what about all these remarkable morphological traits that I just present to you? How those traits evolved within the genus? And where and when did Prosthechea originate? So to tackle these questions, we developed this phylogeny. It was just recently published in the last fascicle of Taxon. So to do so, we could like sample 80 species of Prosthechea, which is kind of 3/4 of the known diversity of the group. Also 11 species of 7 related genera, as highlighted here. We took Arpophyllum gigante, which is like the sister group of Auriman and our other like Laeliinae to root the tree. And so summarizing 92 samples, and it's important to point that we could like sampling all the type species of those alternative proposed genera. So to do so, we took advantage of several like living collections in Brazil and Mexico. Also the DNA samples that Gerardo and Cassio already had in their DNA banks. But also we did some field work, most in Brazil, like in Eastern Brazil, in the Southern Atlantic forest of Bahia, such an incredible realm of biodiversity in the region. Also in Northeast Minas Gerais, in some inselbergs. So we could put together this pretty nice sampling. So we built this Sanger sequencing data set using like 4 loci, ITS, and these 3 plastid markers highlighted here. So we relied on Bayesian inference analysis of the combined data set to discuss our results. So here's like the phylogeny of Prosthechea. So first of all, Prosthechea is strongly supported by posterior probability. Unfortunately, we couldn't recover who is the sister group of Prosthechea, since it was recovered like in a polytomy here, together with other clades including Osmophytum, Encyclia, and Laeliinae and Moana. And now getting into the classification discussion, so to split or not to split, we can check that. Oh, sorry. First, in the Chiron and Castaneto classification, you can so in colors here is mapped like the alternative proposed like circumscriptions. So by Chiron and Castaneto, you can see that the groups are non-monophyletic. And turning to the Witten and Harding classification, you can check that Euchile, Hormidium, and Panarica are monophyletic groups, but all pretty small and just with a few species with a really similar morphology. Whereas their narrow sense of Prosthechea, Pollardia were polyphyletic, and Anacheilium as well is non-monophyletic. So unfortunately, we remain with this polytomy on the backbone of the tree. But even though, like discussing about the situation of Anacheilium, for instance, like someone can argue, like, oh, what about if, let's say, Tiago, if clades E and F with more data are recovered, like together with this larger clade M? Like, even though Anacheilium would be paraphyletic, with since like Hormidium would be nested within that. And then some important aspect here is that if like hypothesizing about like a scenario of better resolution with this situation that I just mentioned, in any case, Hormidium is actually an older name than Anacheilium. So the idea is pretty much, kind of forget about Anacheilium based on this data. But what to do, like let's say the situation about the Anacheilium, but in any case, would remain with like some clades like this clade I, where you have resupinate flowers, non-resupinate flowers, anti-labellums, trilobed labellums, plants with just like pretty like remarkable morphology, such like Prosthechea vitellina. So how to classify a clade like this? Propose like a bunch of even narrow genera, maybe Prosthechea vitellina as a monotypic genus. So for that reason, we didn't see like advantage in trying to split Prosthechea, and for that reason, we defend pretty much just keeping the original circumscription proposed by Higgins based on those morphologies aspects that I mentioned of the clinandrium, the fruits, and also these common traits in terms of vegetative morphology. The pseudobulbs usually laterally compressed. We also did some reconstructions of morphological traits. So here I'm just highlighting what is the outgroups to facilitate visualization. So we can see that this about resupination. So despite we have this larger clade with non-resupinated flowers, we can check that non-resupination evolved more than once in Prosthechea independently. The same for lip lobulation. We have like a larger clade with entire lips, but it also evolved independently other times within the genus. Turning to type of callus, we can check again that we have this larger clade with simple pad callus, but again, evolved more than once independently. And about inflorescence architecture, this is like an interesting result. It was the single trait that recovered like as evolving once in the group here at this clade. We also did some exploratory analysis. Let's say that's not in the paper. I would like to highlight this. So this is in my thesis. We just to explore some biogeographic aspects. We did this Bayesian binary MEC analysis. So I mean, we didn't felt comfortable about like running like a beast tree, knowing about that polytomy on the backbone. So we just relied on a more, let's say, simple analysis. So anyway, we divided the Neotropical region in these 9 bioregions highlighted here, and we could like track that likely Prosthechea originated in Mexico, and by Mexico I mean Mexican western of the Tehuantepec isthmus. And then it was dispersed towards South America till reach the Brazilian Atlantic forest. So this is an interesting kind of pattern because as in several other Laeliinae, even Epidendria, I would say, we have this common pattern, which kind of contradicts a bit that idea of the Amazon as the main source of the, neotropical flora assemblage. So kind of an interesting result. And more recently, I have been playing again with this Sanger data set, and now I did like some maximum credibility tree using Beast2, but not to explore again reconstructions, but just to have an idea of how old is Prosthechea. So we could, like using two secondary calibrations based on Perez Escobar 2017, we could track recover a Prosthechea with 7.58 million years old. So the crown age of the group on the late Miocene. But you can check here that most of the, unfortunately, like the colors were not like really highlighted, but we could check here. Let me just, oh no, sorry. We can check here that there's several, like most of the cladogenetic events are concentrated during the Pliocene and the Pleistocene, so probably like related to the Andean uplift and the, all the glaciation cycles during the Pleistocene. But again, this is just like exploratory. I just want to share that with you, but I want to explore more this sort of data, this sort of analysis. So currently, I'm enrolled in this Harvard University Herbaria postdoctoral fellowship under the supervision of Professor Chuck Davis. And there, we are developing these phylogenomics of Prosthechea, so pretty much like resampling the phylogeny that we did before with Sanger, but not like putting more data on our data set. Sorry. So we are using like an hybrid-seq approach, like mixing target capture with a bit of genome scheming. And we are using the kits developed by Ezerman and colleagues in 2021, like a couple of years ago, like the Orchidaceae 9063. So we have a pretty nice sampling, as you can see here. And in parallel to that, we are also developing this more alpha taxonomic, let's say, based side of the project, which is like concerning about the systematics and taxonomy of the Prosthechea crassilabia complex on the Andes, Central America, and West Andes. And again, we are like in a team of collaborators. So again, of course, Gerardo and Cássio, always together. But now we also have together with us Dr. Adam Kahemans from the Lancaster Botanical Garden. So a pretty nice network of collaboration among like several institutions in the Americas, right? Which is pretty cool, I think, at least. I think that science must be collaborative. And to end, I would like to acknowledge the State University of Feira de Santana and its grad school in botany for CAPES for my scholarship during the PhD, CNPq, and this grant for which covered like most of our sequencing costs. To Fundação Flora de Apoio à Botânica and the Flora project that I was a grantee from 2017, where I could spend like 1 year at the Smithsonian National Museum of Natural History, and also to the Harvard University Herbaria for the travel grant that I got during my PhD, which, so there's both last situations that I mentioned, like allowed me to start building like an international network abroad. So that was really important for my career development. Here's some names of people that facilitated either bench work or sampling. So people that's very kindly sent vouchered materials. And so I'm really, really grateful for all these names cited here, people that really were crucial. And to finish, of course, I couldn't like finish my presentation without like acknowledging like Cássio, my former PhD advisor, and Gerardo, our collaborator, for such for all the support, all the guidance, and also all the patience, of course, most important, I would say. And to finish, I finish with this Prosthechea abbreviata, a species originally described from Costa Rica. The type is from here. And thanks for your attention, and pura vida.
Thank you. We have time for a couple of questions.
Hey, Tiago, nice talk. are you into to produce an infergeneric classification, and how would you deal with this clade?
Yeah, you know, one of the objectives of my PhD thesis was to provide like an infrageneric or sectional, whatever kind of classification. But you know, based on the topology that I could recover so far, I just, you know, I'm not gonna get into that now. So let's see if the phylogenomics data, if you know the topology changes a lot. I don't know. Let's see. I mean, it's a combined data set, right? So let's see with more data how it comes. And yeah, but I mean, I'm really into like taxonomy, you know. So yeah, I would like to propose like a sectional, like something that can be like useful and functional for like taxonomic treatments and this kind of stuff.
Another questions or comments? So thank you very much.
Sure.